All right, let's see what we have. All right, you want to start with 3?
Sure. Yeah, we can start with that one.
Okay. So what are your variables?
So x would be equal to the number of days, and then y would be equal to height.
Yeah.
Cool.
Now, why it's that way and not the other?
Yeah, I don't get that either.
Well,
Uh,
let me think if there's a good reason why we wouldn't want height to be the x variable and number of days to be the y.
right.
Might not be a function that
Mm-hmm.
way. Well, question is, would we have multiple y values for the same x? And notice that we would.
Mm-hmm.
In other words, if we were to do it the other way around, we would have an x of 8 and 8, and we would have a y of 20 and 22.
Yeah.
So the only way to do this so that it stays a function,
Mm-hmm.
remember a function has to pass the vertical line test, which means you can't have multiple values of x, or excuse me, the same value of x being equal to multiple values of y. So
Mm-hmm.
that's the difference. And
Okay.
with this case, if you let x be the number of days, then you don't really have that. Yes, you do. At 20 days, you have 3 different values for y. Well, let me think about that for a second.
Yeah. This is a difficult problem. Like I was having issues with it earlier.
I see what's going on. This is not a function.
Okay.
In other words, when you have a scatter plot,
Mm-hmm.
you end up with a bunch of points, okay, that
Okay.
tend to look like this. Well,
Right.
these points don't represent a function. Notice that right here, I have a value of x that has 2 values of y. In
Okay.
other words, these scatter points would not equal a function. They're
Okay.
not supposed to.
Right.
In other words, the whole point when you have a bunch of points like this in a scatter plot is to draw a line through them that best represents them.
Like the line of best fit, right?
Exactly. And that's
Okay.
what a linear regression does.
Mm-hmm. Yeah, we've been doing that on the calculator, or graphing calculator.
So the only way to answer B,
Mm-hmm.
it's easy enough to make the scatter plot. Well, I'm not quite sure what these numbers are that you've written here.
I just like, I don't know.
That's a little different than what that is involved in. When you're
Okay.
trying to figure out if things have a linear relationship or a quadratic relationship or something like that, then you start looking at their difference. In other words, the difference is 4 there, 1 there, 2 there. But in this case, you don't want to do that. These numbers above the number of days are not, the difference is not significant.
Okay. When would you want to do that?
That's when you have a
Like
table of values and you're trying,
like number 4?
I don't know, I haven't looked at 4
Or,
yet.
oh, okay.
Not
Yeah, my bad.
necessarily number 4. No, I don't think number 4. Number 4 is
No.
going to be a similar problem as number 3, which is going to be you're going to do a linear regression on it.
Right.
Okay? Well,
Okay.
linear regression is quite different than a table of values that are related either linearly or quadratically.
Okay.
Okay, so that's a completely different problem.
Okay.
So in these two problems, I believe, I haven't looked at 4 yet, but in problem 3, it's a straight regression equation.
Mm-hmm.
And what that means is, what is the equation of that line? Well, we know y equal mx plus b, right?
Yeah.
But what
Can you
happens
like?
is when you plug in these data points into your calculator, into list 1 and list 2,
Mm-hmm.
and then you ask your calculator to do a linear regression of those two lists,
Right.
it gives you M and B.
Okay.
Let's say it tells you that M is 2.7 and B is 8.
Mm-hmm.
Well, that means the line that it's telling you is the least squares fit is this line right here.
Okay.
Okay, that's what that means.
Mm-hmm.
So, I guess the next question I have to ask is, do you know how to put in two lists into your calculator?
I do. Yeah.
And then do you know how to request a linear regression?
I do. Yeah.
Go ahead and do it right now and tell me what you get for M and B. And it might even ask you, I believe the Inspire does even ask you when you request a linear regression, do you want it in y equal mx plus b format?
I think it does. Yeah.
And
Let me
if you
plug
request
in.
that, you'll get an M and a B. Let's have a look
Okay.
at what M and B are. Since I don't have those lists in mind, I can't really do it, but I think you
Okay.
get the idea.
Yeah. Hold on. 27. What? Yeah. And hold on. Let me plug that in.
And the only two numbers it should give you are M and B. It won't give you a lot. It might give you a correlation fit or something. It might give you an R or an R squared.
Yeah.
The main thing is to get the equation of that line.
Right. Hold on. I lost my spot for a second. There we go. Got it. 10, 15, 16, 16. Man, that's a lot. Okay, and then we go to menu 413. And then we would type in days and then height. Still trying to get used to this thing.
Yeah, there's a big learning curve on that calculator.
For sure. Okay. So I got y is equal to 0.621 x plus or minus 4.807.
Okay, like that.
I yep. Yeah.
Okay.
Okay.
Now we can answer the other questions. After
Yeah.
15 days, how tall would you expect a bean plant to be?
So you just plug in 0.61 times 15.
You'd plug in 15 for x.
Yeah. Minus 4.87.
Well, now hold on. You'd plug in 15 for x and figure out what that number was.
Okay.
Okay? Yeah, and when you plug in 15 for x, multiply it by 0.621, come up with a number, and subtract off 4.807. So
Okay. That makes sense.
we want to look at the answer because we want to see that it makes sense. In other words, based on this table, it needs to make sense.
Yeah. Like when I graphed it, I just got 1 point on the line.
Here's where the graph should look like. We know that it has a y-intercept down here at minus 4.8.
Mm-hmm.
We know its slope is flat,
Right.
so it looks something like that. This
Yeah, mine doesn't.
is
That's,
0.621.
yeah. Huh.
At this point, I'm not certain what you're looking at. The one thing that's really hard to do online is to see your calculator.
For sure.
Um,
It's weird. I just got 1 point on the
as
x-intercept.
long as it gave, well, that's all you should have on the x-intercept is 1 point. Remember, this is
Yeah.
what it looks like.
Mm-hmm.
It's only one x-intercept.
Right. And then you would find,
Well,
how would you
the
do
first
it?
question is, after 15 days, how tall would you expect it to be? Plug in 15 for x and see what you get for y.
Okay, so to do that, would you just go to menu and then
I would just
trace?
multiply 0.621 times 15, come up
Mm-hmm.
with the number, and then subtract 4.807.
Okay. I got 7. After 15 days, I got, well, wait. Um, After 7 days. Oh wow. Yeah, that doesn't really help. Um, so
Y
yeah,
of 15 is basically what we're talking about here. What is y of 15? Plug in 15 for x, what do you get?
yeah, let me do that. Hold on.
Just do that separately away from your formula and everything else.
Yeah, and it'd be 15. Alright, let me zoom out real fast. That's the 4. Ah, there we go. And then you would do the, like try to find the
No,
intercept,
no, 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 no.
or
I just want
intersection.
you to go into your calculator, plug in 15 for x, and come up with what a y value would be. In other words, multiply 15 times 0.621. That's
Okay, so it'd be 15 times 0.621. I
mhm.
got 9.31.
Now subtract 4.807.
4.508.
So that's what you would expect. Okay.
Okay.
Now let's check and see if we're anywhere near. It doesn't have to be exact because remember these points are a scatter plot and we drew the line of best fit. So
Right.
15 is approximately there between 14 and 17. And
Uh-huh.
so the height should be approximately there around 5, and it is.
Right.
Okay. Now after
Okay.
60 days, what would it be? What would y of 60 be?
Hold on. Minus 4.807. 32.45.
And we can see that at the 30-day mark or at the 31-day mark, it's 15 inches high.
Yeah.
So it makes sense that at the 60-day mark, it would be 32 inches high. So
Yeah.
you always want to do a check in these kind of questions. By that,
Okay.
I mean check your curve and make sure you're not off by a factor of 10. You should never be
Right.
off by a factor of 10. It might not agree exactly with this, although this
Mm-hmm.
is pretty close because if you double 15, you get 30. Um, so both of those answers are quite reasonable.
Okay.
Okay.
Cool.
When would the plant be 14 inches tall? How would you
Hmm.
do that?
You would plug that in to
For y or x?
Y.
So I would say 14 equals 0.621x minus 4.807 and solve for x.
Right. Okay.
What
That
do you
makes
get?
sense. Hold on.
14, add 4.807 to it.
Yep.
And
18.807.
divide that by 0.621.
30.28.
And that's the x value.
Right.
Well, that's pretty close. At 31, it's 15 inches. So
Uh-huh.
when is it going to be 14 inches? A little bit below, before 31 days. 38 days. Now, notice that some of these questions we're solving for y, some of these questions we're solving for x.
Mm-hmm.
But the key to all of it was coming up with that equation.
Yeah.
Well, the only way we came up with that equation is we had a scatter plot.
Okay.
Notice why this is difficult. It's important for you to understand this. If
Uh-huh.
I have points like this, and that's all this scatter plot produces is a bunch of data points,
Mm-hmm.
okay? Well,
Okay.
there's a few lines I can draw through that. I could draw the black line and call that the least fit, but I
Uh-huh.
could also draw a red line that looks not bad.
No. And then you would find the
That's a
the
different line.
intersection of the two.
That has a different y-intercept. It has a different slope. I might even find that a green line is the best fit.
Mm-hmm.
Well, there's an algorithm that determines which of those three lines is actually the best fit for those points.
Okay.
Okay, and
Yeah.
it's a very complicated algorithm, but that's what your calculator is using.
Right.
Your calculator came up with the black line, the linear
Mm-hmm.
regression. It was using that extremely complicated algorithm that you don't really even need to know what that algorithm is. Just
Mm-hmm.
what you need to know is that's what it's doing. In other words,
Right.
it's figuring out what line best fits those points.
Okay.
And
That makes
it's
sense.
not absolutely clear what it would be. As
Mm-hmm.
I drew a black line, a green line, and a red line, and they all look like pretty good fits to those points. I don't
For
know
sure.
which one was the best one. But if you put in these points into your calculator and ask it to do a linear regression, it's giving you the best one.
Yeah.
Whether it's that one that I just drew or not, I don't know. But I'll tell you what it's based on. If you sum up the distance from every point to that
Mm-hmm.
line and you square it and you add them up, all of it,
Mm-hmm.
it's the line that produces the smallest number.
Okay.
That's how
Cool.
linear regression works. That's what your calculator is doing. In other words, the difference between my black line and my red line, well, my red line is that far from that point, and that far from that point, and that far from that point, and that far from that point. It's going to take all those distances, square each one, and add them up. And
Okay.
that's how it comes up with the line of least fit. Okay.
Okay.
So when would the plant be 1 inch tall?
I said 9 days. I rounded down. It was 9.35.
But you solved for x.
Uh-huh.
The original equation was 0.6x plus 4 point or minus?
Minus.
Minus 4 point what?
4.807.
All right, I'm rounding it up. I don't want to deal with all those decimals. So
Yeah.
when you're asked to say when is it going to be 1 inch tall, you substitute 1 for y and then you solve for x.
Okay.
Okay? And the answer better be kind of between 7 and 10 days, right?
Yeah,
Because we can
that's what I got.
that it's going to be 1 inch tall somewhere in here. I mean, you might think you could look at these data points and automatically say that it's 9, but not necessarily.
Mm-mm.
What does this give you? You get 5.8 divided by 0.6, pretty close to 9.
Yeah.
Whatever that number is. What'd you get for it, did you say?
9.35.
All right.
Yeah.
Did it give you instructions at all as to how to round off any of these?
Not really. He said if it's like 9, he said if it's like 0.5 and above you round up, 0.5 and below you round
That's not what
down.
I mean. Does he want you to round off to 1 decimal place, 2 decimal places, 3 decimal places? That's what's important.
Yeah, he didn't say, so I think we could just leave it like that.
Well, not really. I mean, you need to
Yeah.
know. If you're taking a test, you need to know.
Yeah, for sure.
Because it's never, in other words, your calculator gave it to you the 3 decimal places or more even.
3 decimal places.
All right, well then you can always use that as the standard. If they
Yeah.
don't specify, then
Mm-hmm.
I would use 3 decimal places. So whatever that comes out to be to 3 decimal places.
Okay.
What is the real world meaning of slope in this regard?
Um, so like after X amount of days, the height, or I said at 7 days, the height of the plant is 0 inches.
No? What's the definition of slope? If I told you I had a plant that grew like that,
Mm-hmm.
where X was the number of days and Y was the height of the plant, what's slope mean?
After X
Slope,
amount of days,
slope
the,
means how much it grows per day, right?
yeah.
In other words, up here, after 30 days, it's grown 15 inches. So it grows about a half an inch per day, if I look at these bigger numbers.
Yeah.
But that's the real world meaning of slope for this case,
Right.
is
So
how much it grows per day. If you're
okay.
planting the beans, that's a key thing you want to know. It may not grow exactly a half an inch per day, but
Mm-hmm.
it's going to average growing a half an inch per day. And
Okay.
that's going to be the meaning of that slope. In other words, if this is 15 days and this point here is 30 inches,
Mm-hmm.
well, what is rise over run? 30 divided by 15.
Which is 2. Yeah.
Well, it tells you what that slope means. Slope
Right.
means it's growing 2 inches per day on average.
Okay. That makes
Okay?
sense.
What
Okay.
does the Y-intercept mean?
The height of the plant after each day.
Not after each day.
Or
How many days have
after.
passed at this point right there?
Um. Well, 0
Zero.
days, right?
That's what the Y-intercept always means. This is
Yeah.
when X is equal to 0. So
Yeah.
what the Y-intercept means is the initial height of the plant.
Okay.
Notice that the initial height of the plant is 0. Well, in
Yeah.
this case, if I carry that 0 all the way back to the Y-intercept, the initial height is negative 4.8. Well,
Mm-hmm.
this effectively is not in our range.
Right.
Um, but that's what the Y-intercept means, is the height of the plant after 0 days.
Okay.
So find the domain and range for this situation.
Okay.
Look up at the points rather than the curve.
Yeah.
What's the domain?
I said 7 comma 0 for the range.
Not the range. What's the domain?
I mean, domain is 7.
Not 7. 7 to 34. Remember what
Oh,
the meaning of domain is. The meaning of domain is the allowable x values.
okay.
Well, in this function that they gave us, they only gave us values that went from 7 up to 34.
Right.
They didn't give us 35. They didn't give us 6. So
Mm-mm.
the domain for this problem has to be 7 to 34.
Okay. Yeah, that makes sense.
What's the range for this problem?
I said 0 to 16.
Yeah, that's the
Okay.
only values they have. If they'd have had a 17 stuck in there somewhere, then it would be 0 to 17.
Okay, cool.
In this case, it's 0 to 16. You'll notice
Okay.
even on day 7, the plant is still 0 height.
Right.
It doesn't really start growing until after 7 days.
Mm-hmm.
All right.
Okay, cool.
Let's have a look at the next one. We're not going to be able to take the time to do it.
Mm-hmm.
Just make sure I understand it. Use the following data for your birth. Start with x equals 0. Okay. So what they're telling you is that the x-axis, you don't want to go from 1970 to 1989.
No.
It to go from 0 to 19. Right?
Okay.
In other words, 0 for the year 1970. Therefore, 1971 would be 1.
Okay.
1973 would be 3.
Right.
In this case, hold on, one.
Oh,
Is that your doorbell or mine?
that's my doorbell.
Okay.
Yeah. Hey, Mom!
That's funny. I didn't think that sounded exactly like my doorbell.
You're fine.
I've had dogs barking that I couldn't recognize where it was coming from. I think that's the first time I've ever heard a doorbell where I wasn't sure whether it was mine or yours.
No problem. I was seeing the person show up, so I was like, can someone get it? I can't get it right now, but yeah.
So we'll just get started with a couple of these. We don't have time to do the whole thing, but define your variables.
Okay, I said X is equal to the years of birth since 1970.
Okay?
And then I said Y is the life.
So 1976 X would be what?
Uh, wait, what?
In
Oh,
1976, X would be what?
6.
Okay.
Cool.
What's Y?
And then I said Y is the life expectancy in years.
And you don't have to translate that at all. In other words, the graph goes like this. The x-axis goes from 0 to 19,
Mm-hmm.
and the y-axis goes from 67 to 71.
Okay. Cool.
And change, obviously 71.8. Okay.
Right.
But notice that it starts at 67.
Uh-huh.
Now,
Yeah.
I guess I don't really need to label the grid like that. Let me do that a little different. That's going to be a little confusing. I could put 67 up here.
Okay.
Okay? And then what the line is going to do is this.
Mm-hmm.
In other words, at 0 years since 1970, you're going to live to 67. But if you were born in 1989, you figure your life expectancy, you're going to live to 72.
Right.
So you know how to make the scatter plot?
I do, yeah.
And then figure out the regression equation from the scatter plot?
Uh-huh.
The real world meaning of slope would be years,
Oh.
life expectancy beyond 67 divided by, remember what slope is, rise over run, always.
Right.
So what this is telling you is that your rise over run there is like 5 divided by 19.
Right.
Approximately your slope. So what's that mean? It means the additional years you get to live for every year you were born since 1970
Mm-hmm.
That's kind of the definition of slope.
Okay.
And I think you can probably figure out the rest of these. What the y-intercept means
Uh-huh.
what your life expectancy was if you were born exactly at 1970.
Right.
To figure out babies born this year,
Mm-hmm.
well, you'd have to go out way beyond 19. You'd have to go out to 46 on the x-axis, which would be the year 2016.
Okay.
And
Yeah,
then
that makes.
from whatever equation you get of that line, you could figure out what the life expectancy was at
Mm-hmm.
46 years.
Okay. Cool.
And I think you can figure out the rest of the questions. Some they're asking you to solve for x, some they're asking you to solve for y.
Right. Okay. Cool.
Dylan, these linear regression problems are always fun. Actually,
They are.
well, they're not really. I said that somewhat facetiously, but um,
Yeah.
just because they tend to be tough to do in a calculator because there's so much data to input.
Right.
Once you
For
input
sure.
your two lists, then it's pretty easy
Mm-hmm.
because it comes up with the regression formula on its own.
Okay.
All
Yeah. Awesome.
right, Dylan, I will talk to you, let's see, next scheduled appointment. Let me just make sure I got it for Wednesday at 5.
Yep.
Talk
Yeah.
to you then.
That sounds good. I'll see you then.
All right, bye-bye.
Alright, cool. Bye-bye.